Science from EDC University of Technology, Chandigarh. He submitted his thesis for review and joined IDP in EdTech at IIT Bombay as a research associate in March 2020. His research interests include engineering education, CS education, emerging technologies in education. His other interests include photography, videography, and digital design. He has several journal and conference publications at national and international level. We are fortunate to have Mr. Ashutosh Raina here today to share his expertise and insights with us. So without further ado, please join me in welcoming Mr. Ashutosh Raina.
Thank you. Thank you.
Thank you, ma'am. And now request Mr. Ashutosh Raina to begin today's session on introducing AI and tech studies.
Okay, thank you so much, and welcome. It's been a long week, last day. Fine. So today we'll talk about AI, and we'll also discuss about the ethics that are associated with AI. What are the things that you feel about AI and so on. So first about where I come from. So I did my PhD from Education Technology, IIT Bombay, and so this department offers PhD and masters, and we basically work in four key areas of EdTech. The first is teacher education, where we look at different research methods and do number of projects, do FDPs and all of those. One is the student-centered, where we try to build learning environments for teaching certain topics, certain subjects. Then we have something called the learning sciences, in learning sciences and emerging technologies. Here we are looking at things like, okay, how do students deal with uncertainty? And we look at different ways of teaching, maybe through maker spaces, through tinkering. And then the fourth area that we have is called educational data analytics. Here we are looking at educational data and trying to see, okay, what sense can be made out of it? How can you use that educational data? We also have things like these biomedical sensors. There is a brainwave sensor, skin conductance sensor. We use those things and try to see, okay, so like for example, one of the research is if they are watching educational video, how does the engagement go throughout? And we are measuring that through the biosensors. So just a brief introduction for that. So certain disclaimers. So this session is not actually about learning content or a topic. It is framed around artificial intelligence, but this session is about the pedagogy. That is, how do you actually use active learning strategies to introduce this content. Again, this workshop is primarily about how to make classes more interactive, and they are for you to experience what effective learning, learner-centric methods, feel like or look like. Okay? Okay, certain other things to note. So I have orange slides, orange bar slides, and some other slides. Okay? Whenever an orange slide comes, you have, so you all have your mobile phones with internet. You have to go to menti.com. There'll be a code. You have to put that code and we'll have some activity. Or we'll have some group activity here itself, right? Then these orange bar slides is in-class activities. And just to give you an idea, 40% of those slides are either orange slides or orange bar slides. Okay, so we are going to do a lot of activity here. So for this presentation, my sources are basically these two books. So these are two modules that were developed by ATL, which is Atal Tinker Labs, through Niti Aayog. So I was one of the work group members while we were developing these modules. So I've taken some content from there, and anything else that I've used, I have attributed it for. Okay. So what is this slide? Okay, so let's go to menti.com. Okay. And there it will be asking you for a code. So you can put in this code. So the first question that you will have to answer is this. So I'll just go over and that is a code on top. So go ahead and okay, this is just for me. This data is just for me to know, okay, how do I place the activities? So we have 21 responses. I'm expecting around what, 30, 40? Everybody responded? Okay, so if everybody has responded, let's go to the next one, right? Another one. So I'll just change that and your question should change. Now if you go back and use the same code, you will have a... So now I'm asking which AI platforms have you used? So any platform, any software that you think runs with AI that you have used? How many of you heard of ChatGPT? Used ChatGPT. So I'm guessing I should see a lot of ChatGPT here. Wow, Midjourney also good. Okay, this is quite a spread. We have Code Whisper, we have Copilot. Okay, so I mean, since ChatGPT is one of the biggest words here, that means that most of you, quite some of you have used it. So I mean, how have you used it? Anyone? To do what? Just tried it out, played with it. That's also a valid answer. Yes. I mean, a lot of you have said you have used ChatGPT, so. Okay. Yes. Okay. Anybody tried to think of using it in a classroom or to teach with? Okay. Okay. So I have a fair idea of what all tools you have used. Okay. So let's get to what is AI. Artificial intelligence. So let's focus on the word intelligence for some time, okay? So intelligence basically came from human intelligence, and what does human intelligence involve? Gathering information, analyzing information, decision making, taking action, retrieving information and storing information, okay? I mean, this is general sense of human intelligence. Now, to see what artificial intelligence does, let's look at this diagram, go back to Menti, use the code and say type some tools which do any of those, like gathering information, storing, retrieving. Which tools do you think do such kind of tasks? Okay. Oh, there is a timer. I mean, you can just put your answers. I forgot to disable the timer. Okay, we have Shazam, MySQL, Google Assistant, ChatGPT. Okay. Okay, so again, that was my mistake. So I've used the wrong type of question in Menti. Okay, so there are a lot of tools that we use to gather information. We take information, store it in databases. We have a number of methods. Nowadays, we have a number of AI tools to just analyze information, right? I mean, one of the tools that is used to do anything with information is Microsoft Excel. And there are a lot many improved softwares that now have come. Then again, decision making. So we need information to make some decisions, right? And then taking action. So now if we try to look at how did we transition from that human to artificial intelligence? So first is gathering information. It was automated long back, right? Then analyzing information, we were doing it, but we built algorithms. And then now we train machines to build their own algorithms, right? Then again, decision making. Initially, we had data. We could tell them, okay, if this happens, do this. This happens, do this. Now the machines are learning themselves. Okay, if this happens, what kind of action do I have to take? So even they are taking action. They are able to retrieve information and store information. So basically, that's the shift from human intelligence to artificial intelligence. So as I was saying, teaching the machines to learn, think, decide and act as humans would, right? So let's take a historical perspective of AI. Yeah. So I don't know if we have speakers, but I'll see if my laptop can. So this is just a video. It will give you a historical perspective of what happened, how AI started.
Soon after we built the first computers to perform useful calculations, we tried to program them to solve complex problems. We called the new field artificial intelligence, and it worked. Sort of. We built a powerful machine that could outperform doctors at diagnosing certain infections and prescribing appropriate medications. And we built one that could beat all humans at chess. But the infection diagnosing computer could not easily be programmed to diagnose other types of diseases. And the chess playing computer could not master another game. That's because when scientists tried to build computers that could transition from being successful at one task in one environment to being successful at another task in a different environment, they were quickly overwhelmed by the challenge. They found that they needed to write huge chunks of code to get a computer to devise even a simple, limited solution for a basic logic problem like identifying an object. So while they could pack computers with lots of rules and data and brute force power, something important was missing in the field of artificial intelligence: generalized intelligence. So a group of AI researchers in Switzerland decided to go back and do some basic research about what makes certain humans intelligent in the first place. There were a bunch of different theories to wade through. Some experts defined intelligence as a collection of many different skills in several different areas. Others thought it was one general ability that manifested itself in lots of different ways. Some thought intelligence had more to do with what you know, while others thought it was more about your ability to learn new things. The researchers decided to take the common theme of all those theories and treat intelligence as a measurement of success. Something with general intelligence was simply something capable of achieving different goals in lots of different environments. Researchers were able to combine this re-understanding of human intelligence with new computing advances in order to design a new kind of AI. They built smaller, more flexible programs that, instead of being packed with rules, focus on literally teaching themselves. Computers running these programs create their own optimal way to succeed by testing out all sorts of different options and keeping the ones that maximize their success. A system based on this approach named AlphaZero can not only beat the best chess-playing programs at their own game, but can also learn to play and win the exponentially more complex game of Go. And it's not all just fun and games. An AI system based on these same techniques recently learned how to use pictures to identify eye diseases better than the world's best ophthalmologists. The AI researchers aren't programming these systems directly. The systems are figuring out how to succeed on their own. As a result, the researchers are not exactly sure why this new AI is able to perform so much better than the previous AI, or humans. Perhaps that's for some other researchers to find out.
Okay. So were we able to get the gist of what they were trying to say, right? Okay, so again, activity here. So individually think for 1 minute and just pick an option but think individually, okay? Everybody has an option in mind? Okay, now you have to tell the option, but the way you do it is you keep your hand like this and do this, this or this, okay? Yeah. So I see a lot of 2s, a few 3s, no 1s, okay? Now you can discuss amongst yourself, amongst your tables and see what options you had, right? If you have a different option, either you have to get convinced or convince the other. There is no other option. All are 2. Okay, great. Do we have a consensus? So do we have consensus? Okay, let's pause the discussions for now. Let's pause the discussions. Next step, again, re-poll. Now you have to take another decision and same way you can basically lift your hands and show your decision. Okay. Your entire group is 2, right? 2. Okay, so what I see is number of 3s have reduced a lot. So there is only 2 in the consensus. So yes, 2 is the answer, which is training them to learn. Right? So this was the activity. This was an activity just right out of the video. The content that you have seen now to see, okay, kind of a reflection spot. How many of you have ever used this before? Teachable machines. Anyone? Okay, so let's use it. So if you have your laptop, you can just search for teachable machines and get there. teachablemachines.withgoogle.com. Yeah, it's teachablemachines.withgoogle.com. You can Google teachable machines and you will find it. So basically what this tool is, it will allow you to quickly upload some data in the form of either images or audio, or you can use the camera and do some poses, and then it will build an algorithm to identify what you are doing, right? So you basically train it and then you see what the result is. So let me start with the image algorithm. You guys can also try something out. So we have 2 classes. So for first class, suppose, so what I'm going to do is, I'm going to train it with images of me wearing a mask and images of me not wearing a mask, okay? So I'll mask, no mask. So, I mean, there are a number of ways to do it. You can either upload images or you can just use the webcam. I'll just use my webcam. Okay. So, I'll put on the mask and just click on so here it has taken some sample images, okay? And now I'll click on this. Okay, it has taken some sample images. Now I'll click on train. So it is preparing the training data, which is these images, and it is trying to train the model. So now you can see there are two, mask or no mask. Okay, right now there is no one. So if I come here, the probability is towards mask, sorry, no mask. It's saying, okay, I am not wearing a mask. If I put on a mask, it is showing mask, no mask, right? But now check this. Okay. See? Right? So yeah, so this is, sorry. So this is basically for you to try out various options. So like as he said, so if I'm keeping a mask somewhere here, it's not working out. So AI does not happen just like that. So there are a lot of cases that you'll have to look at. There are a lot of scenarios, like I'll have to train it for me with hands or mask somewhere but not on my face. So there are a lot of scenarios that you'll have to look at, right? But again, this is a very quick and easy way to introduce how machines can learn with data and build a model. And you can save these models on Google Drive, right? You want 5 minutes to try it out, or can we go to the next one? Next. So the next, another, yeah, okay. So another, another interesting application is called Draw Together. So again, this basically at the back works with TensorFlow, which is basically another system by Google, which using which you can create humongous AI-based apps. Okay, they have a lot of algorithms for say visual data, text or audio data. So let's try that out. So if you reach the sketchpad, there is something called a sketchpad. There is this option here. It's called Draw Together. Not that, probably try this URL out, magenta.tensorflow.org sketch RNN demo. Or probably search this, Draw Together with a neural network. So I'll switch to the, so this is again an app where you can just play with and try to see how AI or what are the various things that AI is trying to do. So basically you can select any one of these. Say I select a bicycle, okay. And so now what I'll do is I'll draw some very minimal amount on the screen, and the AI will try to figure out what I'm drawing. So if I just do this, again not very accurate, but again if I try to say draw this, so here the network is trying to, this application, it is trying to see how can I complete the diagram? Since I've chosen a bicycle, so whatever I draw, it will try to complete it to look like a bicycle. Like even if I draw a straight line, now it's not able to determine which way it should go. Yeah, it's written there. It's written there. So I have chosen that. I have chosen that this is the object I'm trying to draw, but how should it appear? I don't know. So that is trying to figure it out. So if I say draw one more line here, another here, now it is trying to draw something. But again, not very accurate. This is just a demo of, okay, what are the kind of things that AI is, simple things you can do with AI. Okay. So we come to this question that, so how can computers do all that? But before we get into how computers do that, let's try to think of how as humans we learned, right? How did we learn a language? How did we get to know that fire burns? And how did we get to know that there are some rules that we must follow, right? So to do that, since it's an orange bar slide, this is an activity. So now again, you have to think individually for 1 minute, okay, and say write down points on how do you think humans learn. This is just to help you think that how did we learn a language, how did we get to know that if you put something in fire or if you touch fire it will burn, how did we get to know that, okay, there are some rules that we have to follow. So you need not worry about the correctness of the answer. There is no correct or incorrect answer. Okay. So everybody has 1 or 2 points. Second, now in this part, what you have to do is you have to pair with the person sitting next to you. If you are three people, you can discuss amongst yourselves and take 2 minutes and talk about what you have written. What do you think is the answer? So we have some thoughts. Yes? Okay. Now is the time when you share your thoughts. Okay. Now what we'll do is we'll go group by group. First you volunteer. If you don't, then I'll choose. So go ahead. Mistakes. Yes. Observations. Okay. I forgot I have to write that also. Okay. Mistakes, observations, experience, interactions, listening, sensing, sorry? Rewards. Rewards. Okay. Sorry? Feedback. Imitation. Okay, so we have a lot of responses and let's try to see what I was getting to. So we have a mix of responses, mistakes obviously. So mistakes, if we look at it, mistakes are kind of a feedback, right? Again, observations, experiences, sensing could be something which is like a sub part of observation and experiences. rewards. Yes, rewards and feedback. Rewards, I mean the feedback basically either it's rewarding or it's some negative feedback, right? So let's look at what. So basically if we look at how we learnt is, like I was taking the fire example. Initially if either someone has told you that don't do it, or you have experienced that okay it burns, then you register it in your mind and now you have an image of okay if something is of this nature and this color it might be hot, right? There are certain characteristics that you are associating with it, okay? Then you store it in your memory and you also store the experience, which is like, so either if it was someone who scolded you, so you are storing that experience, okay this is not something that I should do, or if you say touch fire at a very young age, you stored that experience of okay I should not do that, right? So next time when you see it, all these things they come back to you, right? So this is just a flow of how we have learned. And now if I try to map it with how machines learn, machines also take data, they have some processing algorithms and there is an output. And what happens is either they learn through instructions, we call that supervised learning in machine learning. By trial and error or punishment or rewards, we call it reinforcement learning. We are reinforcing a behavior, right? So basically, like we were seeing in the video, so they said they created some algorithms which were able to learn themselves. So what they actually gave the algorithm is they gave the rules of the game. Suppose it's trying to learn a game, they gave the rules of the game. Now algorithm is trying multiple possibilities and it is seeing whether is it able to win or not, right? So if it wins, it is keeping that in the memory. Okay, this is something that I have learned now. So that is reinforcement learning. And by observation is, so as kids, human kids, we have this nature, I guess not even human, most of the living organisms, they have this nature of doing pattern recognition. They try to observe patterns, pattern of different things, sounds, what they see, and they try to make sense of patterns. So that is what we call by observation, that is unsupervised learning, right? So I'm just trying to translate how we learnt and how we are taking that and trying to implement it into AI, right? So as I was telling, there is something called supervised learning where we tell them, okay, these are apples, these are bananas, like we just did, and then it can identify. Or unsupervised learning where we just give them some images. The machines have algorithms like clustering, classification algorithms, and it tries to create certain patterns, tries to create certain characteristics of each of them, and then tries to classify them into different things, right? Or there is reinforcement learning where they are getting rewarded for certain actions and not for the others. So they keep learning that. So again, reflection spot. Teachable machines. We just tried teachable machines. So it was an example of, you can speak out, supervised, right? Anybody who thinks otherwise, we can do a convince or get convinced. Okay, fine. Yeah, supervised is the answer. So lot of AI till now, right? Yeah. So let's step back and try to see through this small session where I try to introduce AI to you, what were the kind of things that we were doing, right? Again, another activity. So individually for 1 minute, think of what are the kind of activities that we were doing when we were getting introduced to AI. Make a note of them, think individually. So now you have to take a step back and take the teacher's hat and look at what we were doing in the past few minutes. This is think. We only think individually, no talking right now. So do we have some answers? Yes? Okay. Any guess what is the next phase? Discuss with each other. Yes, pair and discuss. Okay, again these are just to help you. So this is not the answer. So think in terms of the activities we did. Like what were the activities that we were doing? So do we have some groups, some ideas? Can we go to the next phase now? Anybody needs more time? Okay, so again, volunteer or get chosen. Again, there are no right or wrong answers. Yeah. So somebody was saying introduce tools. Yes. Tools. Anything else? Okay. How humans learn. Reducing the effort. Can you elaborate more?
Like if I need something should be there, some system should be in place to solve our problems.
Okay. So now
I'm not doing the one word.
that's okay. So now try to think of it in terms of the kind of activity we did to reach that realization. That suggestions.
Some optimizing.
Okay. Sorry. Okay. Giving some instructions. Then okay. Any other answers? So I have not heard the answers from that group. I need one. Sorry. Okay.
Developing rule-based systems, smart systems.
Okay. So let's look at this question for a minute. So the thing was, how was AI introduced to you as learners, right? So as you all said, so we looked at a lot of tools. We looked at how humans learned. We saw some platforms and tried to, try AI, right? We also talked about certain suggestions, designing robots. I mean, this is all, we are talking about content. So if you look at it, you see how is the content being introduced to you. So now, if you look at the question, how is AI introduced to you? So there was some part where I was telling you, I was giving you information. There was some part where you were experiencing the concept through teachable machines, through certain discussions that we had. Then you all had interactions and you yourself came out with the answers, right? Right. So we did these kind of activities for introducing AI. So what we were trying to do right now is basically active learning. So you are being introduced with AI by experiencing it and doing activities, right? Have you heard of active learning before? Huh. So have you heard of active learning before? Yes. Do you know of any certain activities that associate with active learning? Yes. We did a lot of think, pair, share. We did something else, a variation in beginning where we did this hand signs. We'll come to that. So go to Mentimeter and write certain activities that you think are active learning strategies. Active learning basically is when we are actively engaged with the content and through the experience we are learning. Again, no right or wrong answers, just give answers based on what you feel, what your perspective is towards active learning. Okay, I am seeing a lot of people Googling active learning and then trying to write. That's also fine. Case study, think, pair, share, group discussions, yes, all of them. Fishbowl, that's interesting. Hands-on workshops. Experiential learning. Brainstorming, peer learning, flipped classroom. So we have around 20 responses and we have experienced think, pair, share right now, right? So yes, group discussion is also a valid active learning strategy. What you need is there are certain things that you have to take care of. You have to take care of the orchestration of the group discussion. There has to be a focus question. That focus question then has to be discussed and the discussion has to be summarized, right? Again, case studies is also a similar thing. Once you give the case study, you can always have a debate. It can be online, offline, anything. But again, that summarization and reflection is what is important there. Experiments. So someone wrote fishbowl. Can you share what fishbowl is? Okay.
So the inner group discusses some concept, someone outside notes down, and then they summarize.
Oh, that's a very interesting one that we got to know. Right? So yeah, so there are a number of active learning strategies that we can use. So now let's discuss two cases, okay? So there is a case of teacher A and a teacher B. So just read what teacher A does and teacher B does. So now we're kind of shifting focus from AI to more active learning, what is active learning and how things happen. Okay? Right? Now, every table can take a side. One of you have to talk for teacher A, other for teacher B, right? Instead of the classroom, I'm just saying tables. I mean, pick one. There is no right or wrong again. And discuss for a while. Take notes of, write some points, what teacher A does and what part of teacher A's method is better and what part of teacher B's method is better. Again, these are two perspectives that you are taking. There are no right or wrongs or good or bads. Do we have some points for both of them? Teacher A, teacher B? All the tables? Okay, again, so volunteer or be chosen. Sorry. So let's have some points for teacher A. Yeah, teacher A. Demos for problem solving. Discipline in class. Systematic intro. Yeah. Sorry? Flow with the. Sorry? Yeah. Sorry? Okay, so we were looking at like the strengths of A and B. So we are looking at strengths only. So passive learning is the strength, one-way learning is strength. I'll write it if you feel so. Okay. Go home. I mean, please share with us, even we want to. Okay. Fine. Students practice at home. Yes, at home. Okay. Should we move to teacher B now? Okay. Go ahead. Sorry? Active.
Students and teachers are
Okay. Two-way interaction and feedback. Retain better, explore. Explore new paths, and there was something else from there. Different perspective. Attendance. Attendance. More. Sorry? Okay. So excuse my typos, trying to listen and fine. Any more points? Yeah, creative, innovative. Okay, so let's see what points I had in my mind. So, basic conceptual knowledge is given, right? They can do demos, we talked about it. Clarification questions. Then students develop listening skills and assimilation skills, and there is limited time, right? So, in teacher B's case, students do tasks, exploring complex tasks, multiple solutions, make correct mistakes. Like you were saying, there is creativity, innovation, because there are many ways of doing, explore new paths, right? Again, develop potential and confidence when they are talking, when they're discussing with each other, they're getting that confidence that, okay, we are what we are thinking, it's the same, but everybody else is thinking. You get a feedback there. and that what contributes to peer learning, right? And there are some other aspects like team building. This kind of process is enjoyable, right? So why do we have a teacher A and a teacher B? So as I said, there is no right, wrong, or these are just two perspectives that we are taking. So long back, information was something which was not freely available. At that time, teachers had this role where they had to provide this information, right? And that was their key role that they were playing at that time. But now that has changed, right? So since information no longer is not the premium, I mean information is readily available everywhere, rather extensive information and sometimes a lot of misinformation is also available everywhere. So the role of a teacher here is shifting. It is shifting from than being a person who transmits, he or she transmits knowledge, is to allow the learners to experience how to get the information, assimilate that information, apply that information, and through different practices, how they can do that, right? So that's the point of teacher A and teacher B that I was making. So the focus has, so earlier that was a teacher centric role where teacher was giving information. Now what they have to play is something of a student centric role, where the teacher has to think of, okay, what is that the student requires. And active learning techniques are one of the ways. So basically active learning is about engaging students with content, specific activities, and what can the activities be? Talk, write, reflect, express their thinking. And we did all of that, right? Now, is it that I am just talking, so on what basis am I saying this, right? So there has been research and there is empirical evidence for it. So again, another activity, as I said, 40% of my slides are activities. So I'll present some 5 scenarios, okay? When you are going through the scenarios, write what a teacher is doing, what a student is doing. So you can make like 2 columns, teacher, student. Next, I'll move to the next one. Next one. The last one. So if you have your points, I will leave that previous slide. Now you can again hear and start discussing what points you have, and as a group, what are the points that you have. So now let's get into the discussion. Do we have some consensus among groups? Okay, let's share now. Please go ahead. Okay. Okay, first one. Okay. Students, first scenario, students. Let me keep the scenarios. Students are trying to listen, trying to understand. Okay, yes. So let's talk about the second one. Yes. So here, if there are any doubts, teacher is asking. But so I'll put this question to you based on your experience. How many students do you think actually ask the doubts that they have? Yes, right? So now in the third scenario, what has changed? So now here students are talking to each other. So at least those few students who were not able to ask the question, at least discuss it, right? They might be more comfortable at least discussing. So now what happens in fourth scenario? How does the role of teacher change? Please. Yeah. Yes. So what do you think at this time the teacher does? Yes. So basically the teacher is walking around, right? They're talking, looking at what people are doing, talking to them, right? And fifth one. Yes, students are thinking very critically, they are trying to argue about things, right? So, let's see, students are doing more on their own in the later ones. More meaningful activities like writing, discussing, solving problems, more engaged with the content, more collaborative discussions on content with each other, more reflection on what they're learning. So teachers are becoming more of facilitators than, but at the same time, out of class, there is a lot more thought that has to go into the session, right? So basically that's how more active learning happens. So basically 1, 2, 3, 4, 5, we were just trying to see different scenarios of how gradually you can get your class into this. So this is one diagram that we have from, basically how can you start is basically you take 10 to 12 minutes of a lecture, then at least have 3 to 4 minutes of turn to your partner kind of activity. Again, a small lecture and then turn to your partner kind of activity, and then again lecture, but at the end, very important is the 5 to 6 minutes summary. Now this summary can either be through the teacher or the students can be asked to reflect. And there are a lot of tools, like one we are using called Mentimeter, where, so with Mentimeter, the thing is, it's a free tool if you have 3 slides. That's why the next set you have a different code. With one code, you can have 3 activity slides for free, and the next one, then you'll have to create a new slide. That's fine, just the code changes, right? So they have a lot of options. You can use that so that everybody is able to, contribute and discuss about it, right? So yeah, so I have been talking about it. Here, one thing about active learning is it tries to ensure most of the students participate, right? And the other thing is when you do activities, you actually get to know misconceptions, because here you're not waiting for a feedback. You give the lecture and then you take some time and then the exam comes and then you feel, okay, this question a lot of people have not got it right, probably there is a misconception happening. If you're doing activities, the misconception will come out pretty soon, right? From the level of, if they think they are able to understand, they are actually getting to whether they know they understand or not, because they are applying that knowledge right at that time. But is there is there any empirical evidence for it? So this was a study that was conducted. It was a comparative study of 62 physics courses. The course was trying to teach force concept inventory, right? There are around 6,542 students and a variety of institutions, which were college, school, universities. So what they did was they did a semester-long study, and there was a pre-post kind of a observation. Pre-post is basically before the class, after the class they were trying to take data, right? So I'll try to explain this graph. This is a bit complicated graph. So here you have fraction of the course, and this is basically the learning gain. What is the learning gain? It is your post minus pre divided by 100 minus pre. That is how your gain is calculated. So so red are basically traditional lectures and green are active learning strategies. So what you see here, when the fraction of the course, 50% of the course is traditional lectures, the highest gain that you get is 0.28. Right? So if 50% of your course is traditional lectures, then the maximum gain you can get is 0.28. For them, 0.24 of, 50% of, yeah. So this is where most of their observations were, where 50% of their courses were traditional and the learning gains were 0.24, right? The observations that were taken. But if you look at the case of active learning, even if 0.2 of your lecture is active learning, your gains can actually shoot up to 0.72. So in this study, what they saw was the maximum amount of, it was not even 0.2 amount of active learning strategies that were used for the fraction of lecture, but the gains were actually at 0.6 and 0.64. Right? So this graph is making sense now? So it is desirable to involve active learning strategies in our teaching and learning, right? This is the article I'm talking about. This is the paper I'm talking about. You can read it if you want. So there's another one. Now this is a meta-analysis of another 225 studies. So what they say is, but just by having active learning technologies, active learning techniques, the course grade went up by 0.5. That is the average. The failure rates 33.8 to 21.8 just by introducing active learning strategies. So there is a difference. Okay, so you had asked me what was that we were doing those gesture wala activity. So that's called peer instruction. Peer instruction is when your peers are trying to instruct you. So I at no point of time told you which the right answer was. The entire group, majority of you came to the right answer yourself. And this, so every time we do this activity, this kind of happens like magic. That even in the class, if you have a 50-50% divide, by the time you do that peer instruction, you will have a consensus towards one answer. And that is one of the ways you can actually spot a misconception very soon, because most of the class will have a wrong answer in that case. Right? Some other thing is think, pair, share. We already tried that. So there are a lot of them. You can read about them.
Sir, I can just go back to previous.
Sure.
Now, in this you are saying whatever 21.8% or whatever it increased. Now, how do they do that testing? Suppose I am taking today active learning method. To that student, how you will find out by active learning method their grades?
So what they are doing is, so there are different type of research designs that they have, right? So in certain cases, they have one control and experiment group. Control group, they will not be doing active learning. The experiment group, they will have different, they can have a pre-post kind of a thing where they recording, okay, before active learning, what is there, after active learning, then you can have a control experiment with pre-post where you are seeing what is the gain in the control group and also the experiment group, right? Break?
Sometimes in this active learning, how do we do a group? How do we do a group also plays a most important role?
Yes. So, yes. So,
What are the strategies to make groups?
so most of the time, what we do is we generally do a pair up around the table 1, 2, 3, 4. But again, like they already have preferences. How people sit are based on their preferences, right? So, I mean, there is not much difference in the way you seat them. There won't be a major difference in terms of the results you will have.
They will be, no?
So again, through what we have seen through this, there is not a major. So on a very class level basis, you might see the difference. On a very class level basis, you might see, okay, for this class, probably these people know each other. That's why they are interacting. Somebody comes here who doesn't know them is not interacting. But if you look at it in the bigger picture of the entire course, this does not happen. If it happens in that case, you can always intervene. And so one of the things that I was trying to do is, I was trying to walk around when you guys were doing TPS. So at that time, if I see that there is some person who is not interacting, I start interacting with them. And then I kind of make them interact with others. I start asking them questions. So what I do is, I won't tell them, why are you not interacting? I'll start asking them questions. And then probably I'll make two people discuss about something. So those are certain ways that you can try to get people to talk to each other. So another way which one of our faculties does is, so if there are some times when you give them an active learning strategy, nobody talks. They're not talking. So my instructor just says that until unless you don't talk, we are not going to go ahead. There is going to be awkward silence. And she is very clear about it. She'll sit, and believe me or not, if you wait there for 10 seconds, 11 seconds, somebody will start speaking up. So you just have to wait, and people will start speaking up. Okay, so before we do that, we can break for some time. Okay? And when we come back, we'll do again more activities.